Our next topic is real numbers. So to understand what real number means, we're going to start from our main set that are natural numbers. And we're going to write it here, that n. And remember that natural numbers are numbers like 1, 2, 3, 4, 5. And we continue to the infinite. So we're going to place our natural number in a box here. And we're going to say that we're having 1, 2, and we continue. Then we learn about the whole numbers. That the whole numbers are the natural numbers plus another number. And that number is 0. So we're going to have here whole number, a W, and then we add here 0. So that set of whole numbers will be holding the natural numbers. Then after the whole number, there are 0, 1, 2, and 3, 0 and the natural number. We're having another set. That is the set that we learned lately. That is the set of integers. And the integers holds the negative numbers. So we're going to have them in the distribution. Integers will be holding the whole numbers and the natural numbers, and our integers are the negative numbers that are -1, -2, -3, and we can continue. But where do we have the fractions? Because here we're talking just about integers, and integers mean without parts. So the fractions are a set represented by the Q and has the name of rational numbers. So we're going to have here fraction like 1/2, 5/4. We can also have decimals, but exact decimals as 0.5, -1.5. We also can have the fraction -1/4. So all these, the integers, the whole numbers, and the natural numbers, all of them belong to the rational number, because we can have fractions such as 8/4. 8/4 is a fraction, but also 8/4 is 2. So that's why the natural number, the integers, are whole inside the rational. But what happened with those numbers that are having a lot of decimals? So those numbers belong into a separate set, and we're going to write it here. Those irrational numbers can be, or they are like the square root of 2, the square root of 3. So all the square root of odd numbers are irrational. The square root of prime numbers are irrational. Pi, that is equal to 3.14, and we can have a lot of numbers, is an irrational number. Or any number that you can create by yourself, like -16.345, and you can continue adding decimals. So those numbers are irrational. And all of them, the natural numbers, whole number, integers, rational, and irrational, all of them are inside a main set that is real numbers. Now we're going to focus our attention on those capital letters that are having like a double mark to identify them, or to make the difference of the name, because those are proper names, the name of the sets, and the regular letters. We're going to start for the natural number. That uppercase N is for natural numbers. Then we're having there a W. The W is for whole numbers. A Z that represent the integers. A Q that represent the rational number. An I that represent the irrational number. And an R that represent the real numbers. So natural numbers begins on 1 and they continue to the infinite. Now the whole numbers begins on 0 and they continue into the infinite. Now the integers do not have a beginning nor an end. So we're going to have here -1, 0, 1, and we can continue. The integers hold the negative part of the natural numbers. Now, the irrational numbers are fractions and decimals like -0.5 or 1/2, 1/4, and we can continue adding fractions that we know them as proper fraction. And all those fractions that you can represent in rectangles, those are rational numbers. Now, the irrational numbers are numbers like pi, that is 3.14, and we can continue adding decimals. And the real number are all the numbers. There is it. Now let's focus our attention on the rational number, and we're having there the definition. Rational numbers are all fractions formed by dividing pairs of integers but without including the 0. We cannot divide a number by 0. 1/0, we can't solve that. -16/0, we can't solve that. Okay, now let's see there. We're having a number line with the numbers from -1 to the number 2, and we're including -1/2 and 1/2. So those numbers that we can easily represent them in the number line, we can say that they are rational numbers because we can place them there. Now let's see. Consider -1.25. That 1.25 can be also written as -1 and 1/4. Now if we place that, we place the number -1.25 or the fraction -1 and 1/4, we're talking about this part here. This is -1, and if the half of the way is this one, so that number, the -1.25 or -1/4 will be there. So we're going to write here A. So we can easily place that number on the number line. Now let's see that one. Consider -3 over -4. We're having there a division of same signs. Both are negative, so we change into a positive. So we're going to have here that instead of having that double negative sign, we can just have 3 over 4. But also, instead of having 3 over 4, we can have the decimal form for that. What will be that? Dividing 3 by 4, that will be 0.75. So we are changing from fractions to decimals and showing that they are the same. So where can we place that number? If this is our half, that means that we're having here 1/4, 2/4, and 3/4. That is the number that we want to represent. So in this part here, we can place our number 3 over 4. Let's see that number there. We're going to consider -3 over 4 and 3 over -4 to see what relationship do they have. Our negative in both cases, or when our fraction is carrying a negative, both numbers are negative. So we can say that -3 over 4 is the same with 3 over -4. The only difference is that our negative that was on the numerator jumped into the denominator, and both of them are equal to have a -3 over 4. Now, you can write a negative fraction in those ways, but the real way to write a negative fraction is placing the negative sign at the same side or at the same level with the fraction bar. The first one are improper way to write a negative fraction, and having the negative sign at the same level of the fraction is the proper way, the real way to write a negative fraction. You can move the negative according to the needs that you can have in a certain exercise. Basically, we can say that this will be fine, but this one will be perfect. And there is a huge difference between being fine and being perfect. Okay, let's see some examples of things that we can do with our rational numbers. 2, 0, and -1, besides being a natural number, whole number, and integers, they are also rational numbers, and or thus they are real numbers. So we can say that having 2 is equal to have 2 over 1. Having 0 is equal to have 0 over 1. And having -1 is equal to have -1 over 1. We are changing the integer into a fraction because we can't do that. It's possible having an integer and just writing under it a 1. So what does that mean? That means that in this fraction we're having here a over b. Also here will be a over b, and in this one will be the same, a over b. Now in this case we're going to say where a is 2 and b is 1, like that. Here we can say where a is 0 and b is 1. Also we can say here that where A is -1 and B is 1. There. Okay, now let's see those rational numbers, because they are fractions and they are fraction and a decimal, so they are rational. Before make any change, we're going to rewrite both into fractions as well, because this one is a mixed number and that one is a decimal. So 4 times 1 is 4, 4 plus 3 is 7. So we're going to have here a negative and 7/4. Now we're going to change this decimal into -1, and 25 is 1/4. Now this one, that is a mixed number, we're going to change it into an improper fraction. So 4 times 1 is 4, 4 plus 1 is 5, and we're going to write here 5/4, and there we have them. Now what we're going to have? We're going to have the equivalent fraction that will be A/B, A/B. There. Now here we can say that A will be equal to -7 and B will be equal to 4. And now in the second one you can say that A will be equal to -5 and B will be equal to 4. Those negative signs can change into 4. We can place them into 4, but just in one number to hold the negative sign of our fraction. We've been working with rational number, and we already saw that we're capable of writing any rational number into a fraction. So when you can't do that with a number, that number is a rational number, and it can be easily placed in a number line. But what happens when we're having numbers such as the square root of 2? You already know what is a square root. That means that we need to look for two numbers that when we multiply them we get 2. But those two numbers must be the same. Do we have any pair of numbers that when we multiply them we get the square root of 2 or 2? No, right? Can we write this number or the square root of 2 like a fraction? No. In fact, if we use a calculator to find that number, we're going to realize that the decimal numbers continue. So let's see. Using a calculator, what will be the square root of 2? 1.41, 42, 13, and we are having a lot of decimals. The same happens when we are looking for the square root of 3. So let's see. Can we write the square root of 3 as a fraction? No. Do we have a pair of numbers that when we multiply them we get 3 as a product? No. So what will be the square root of 3? Let's find that using a calculator. So the square root of 3 will be equal to half 1.7325, and we can continue writing numbers. When you are capable of continue writing numbers, so that number is an irrational number. Let's work with the most common rational number on the math word, that will be pi. We can write pi as a fraction, but that fraction is not rational fraction. It is gonna be a weird stuff, but let's see that. Writing pi as a decimal will be 3.14 15, 26, 54, and we can continue writing numbers. If we write pi in its fraction way, that division will give us the same distribution of numbers. So pi is also an irrational number.